Okay, so in this video, we're going to talk about percentiles and z-scores. Percentiles, what are they? Well, if quartiles divide your data into 4 equal parts, what percentiles will do is it's going to divide your data set into 100 equal parts. So let's use an example here to learn what a percentile is. Let's say we're interested in finding the height. That will be the 90th percentile in your data set. Well, that particular height will be the value such that 90% of the males in your sample will be shorter, will be less than or equal to that particular height. So our sample has 30 students or 30 males, and 90% of 30 will be 27 divided by 30, right? That gives you 90%. And this particular individual is the 27th person in our sample, because this particular sample here, I've arranged them from smallest to tallest. So any value that falls in between here, okay, will ensure that you'll have 90% in your sample that are shorter than that particular height. We denote percentiles as P with a subscript corresponding to the percentile value. And if P090 was 186 centimeters, okay, we can say that 90% of the males in our sample will have heights that are less than 186 centimeters. Let's try 10th percentile. Okay. So 10th percentile, which we denote by P of sub 0.10, is going to be the value such that 10% of the people in your sample are shorter than that particular value. Okay. Well, 10% of 30 people is anybody below this number. Okay. So if we have, say, 169.1 centimeters, okay, this value ensures that this value, okay, when you compare it against the sample, ensures that 10% of your population or your sample will be shorter than 169.1 centimeters. Let's do one more, the 25th percentile. The 25th percentile, denoted as P sub 0.25, okay, it's going to be such that 25% of your sample falls below that value. 25% of 30 is what? Let's see. You divide your data into 4. So let's see, 30 divided by 4, 7.5. Okay, so 1, 2, 3, 4, 5, 6, 7.5. Okay, so if we have a value somewhere here, we ensure that at least 25% of the people are going to be shorter, okay, than that particular height. In our case, it will be 173 centimeters is a suitable value for the 25th percentile. Okay. The 50th percentile, 25th percentile also corresponds to first quartile. The 50th percentile ensures that half of the data falls below that particular value. Okay. We know that half of the value is below 176.4. Okay. So if you have a height of 176.4, okay, we can be sure that 50% of your data in your sample will be less than or equal to 176.4 centimeters. Okay, so there you have it. That's percentiles in a nutshell. Let's talk about z-scores. What are they? So first of all, the formula for a z-score is given by the actual data point, the value of the data, in our case the height of a particular individual, minus the sample mean, divided by the standard deviation. So before we give any kind of interpretation of what the z-score means or captures, let's compute the z-score for a few of these people in our sample. Let's grab the shortest person in our sample. x1 is equal to 165.2, and his corresponding z-score would be, let's call it z1, is 165 minus 2 minus the average or the sample mean, by the way, we had calculated this in previous lectures, was 177.07, and the standard deviation, which we also calculated in one of the previous example, is 6.59. So take away the mean from 165.2, which is 177.07, and divide that by the standard deviation of 6.59. That gives us what we call a z-score of negative 1.80. Let's compute it for the tallest guy in our sample. Let's call him x30, and he's 193.5, and his z-score is at 30, which consists of how much he deviates from the mean in the numerator. So again, the numerator 193.5 minus the mean of 177.07. Remember, we call that the deviance of a particular data point from the mean of a sample data. Divide that by standard deviation. And we get a z-score of 2.49. So the z-score for our shortest guy is negative 1.8. And the z-score for our tallest guy is 2.49. If we take a closer look at how the z-scores are calculated, the numerator contains the deviance of a particular person's height from the mean. So the bigger the deviance, the bigger the z-scores. Okay. So then what does z capture? The z captures pretty much how much a particular person deviates from the mean. The bigger the deviance, the bigger the z-score. Now let's take a look at someone who is closer to the mean. So the 20th person, his height is 178.8 centimeters, and his z-score, z20, will be 178.8 minus 177.07. You can see that the deviance from the mean is very small compared to our tallest guy and our smallest guy. And divide that by the standard deviation of 6.59 to get a value of, let's see here, 0.262. Okay. So the 20th, or the person whose height is 178.8, doesn't deviate that much from the average or mean of 177.07. Okay. Once again, a z-score to characterize how extreme of an observation is a particular person's height. The bigger the z-score in the positive way, or the bigger the z-score in the negative way, okay, indicates that that particular observation is an extreme observation or is not near the mean of your particular data set. If an observation yields a very small z-score, that tells you that that particular observation is an observation that is very close to the mean. And in fact it is. A person who is 178.8 centimeters is very close to the mean of 177.07 centimeters.